when we talked about trig yesterday, it was all about the right angle triangle. So the angles were between 0 and 90 degrees, but obviously angles can be more than 90 degrees. In fact, they can be negative as well. So how do we deal with angles of any size? So we draw up this, number plane, and on it we put our circle. But the degrees, we start with 0 over here. And it's like I was saying yesterday, it's strange how with bearings we do it differently. But we start with 0 horizontally, and then we rotate anti-clockwise. So 90 is at the top, the 180, 270, and so on. The circle splits it up into 4 quadrants, and depending on which quadrant we're in is how we deal with the trig. I like to draw this little, well, I call it a butterfly. What it really is just 4 right-angled triangles. Okay? So there's 4 right-angled triangles there. And the angle that we're going to refer to is always the one that triangle makes with the horizontal. All right. Because we know how to deal with acute angles. So if we can turn everything into an acute angle, we can get an answer. Now in quadrant 1, obviously every angle in quadrant 1 is going to be an acute angle, so it's just normal. We don't have to worry about anything. Quadrant 2, which I call the 180 minus theta, or 180 minus the acute angle. Because if the acute angle is in this position, then the actual angle, if I've started over here, would be 180 degrees minus whatever the acute angle is. In that quadrant, if I think of this right angle triangle, and sine's opposite, and that value is in the positive. The hypotenuse we always assume is positive because we're talking about a distance. And so we get positive over a positive, so sine will give us a positive answer. Cosine, well, the adjacent actually is on the negative side of the x-axis. So we'll get negative over positive, which is negative. And the tan one, adjacent over opposite, sorry, other way around, isn't it? Opposite over adjacent. We get positive over negative, so tan gives us a negative in that particular quadrant. In the third quadrant, and so now we've got 180 degrees plus the acute angle, sine turns out to be negative, cosine's also negative, and now it's the tangent one that's positive. And that brings us to our fourth and final quadrant, which would be 360 degrees, so all the way around, but minus the acute angle. And in that one, sine's negative, it's cosine's turn to be positive, and tan is negative. Now, how you remember that, of course, is up to you. Some people have little sayings like all stations to central and things like that, ASTC. But however you remember. Now I'm going to show my age here. Before we had calculators, oh my gosh, long time ago now, and we wanted to work out sine of 260 degrees. We used to have these tables that you could look up to get the answer, but it only had answers between 0 and 90 degrees. So we had to convert them into the acute angle. So we'd say, 260 degrees, that's in the third quadrant. In the third quadrant, sine is negative, and it would be the same as the acute angle. Well, the third quadrant is 180 plus the acute angle, so it would be 180 plus 80 degrees, we would get 260. So it'll give me the same answer as the negative of sine 180. We would then go and look up sine 180 and go, all right, well, it's the negative of that. Fortunately, you have calculators and you can just press the buttons and go, oh, look at that, negative 9.9848. Isn't technology wonderful? All right. So a similar thing, tan 220. 220 is also in the third quadrant. The acute angle, in this case, 180 plus 40 would give me 220. So it gives the same answer as tan 40. And you might be thinking, well, why do we need to know that? Because we do have the calculators. Well, because sometimes we're dealing with algebra rather than numbers. So we still need to know, oh, that would be the same as the negative of tan x or something like that. Secant. Well, secant is the reciprocal of cosine. 105 degrees is in the second quadrant. Cosine is negative. So it'll be the negative of the secant of, second quadrant is 180 minus the acute angle. So it would be 75 degrees would be the acute angle. Minus the secant. Of course, we don't have a secant button on our calculator. We'd find the cosine of 105 and then hit the reciprocal button and we'd get minus 3.8637. 430, oh no, that's bigger than 360. What am I going to do? You just take off 360. So if you've got a number bigger than 360, you just keep taking off 360 until you get an answer between 0 and 360. And so it ends up being the same as cosine of 70, which is just an acute angle, 0.3420. Negative? What's going on? Tan of negative 67. All negative 67 means is we're starting at 0. Instead of going around anti-clockwise, we're going around clockwise. So 67 degrees in the clockwise direction would be the same as going 293 degrees in the anti-clockwise direction. So tan 293, that's negative, and the acute angle, surprise, surprise, is 67. 2.3559. All right. P is sitting on that circle. It's got radius 5. We want to find its coordinates. The other thing we're told is it's made an angle of 30 degrees with the horizontal. So it would be possible to draw up a little right-angled triangle and just use normal trig. The x coordinate would be the horizontal. So x over the hypotenuse, 5. Cosine 30 degrees. So x is cosine of 30, root 3 on 2. So we get the x coordinate is 5 root 3 on 2. Y on 5, well now we're talking about the opposite. Sine of 30, sine 30 is a half. The y coordinate's 5 on 2. So there's our point. 5 root 3 on 2, 5 on 2. We need to know what happens on the boundaries. We know what happens inside the quadrants. So 0, 90, 180, 270. The way to think about this is I'm going to draw up a triangle which clearly doesn't exist because the angles in this triangle, well, one angle is going to be 0 degrees. And so by angle sum of a triangle, the other angle must be 90 degrees. So clearly it doesn't exist. The base of that triangle is going to be 1, but if you think about it, if the angle is 0 degrees, then the hypotenuse must also be 1, and by Pythagoras, the height is 0. So a very interesting triangle. But I can read off this triangle to get the answers to the boundary values. The sine of 0, opposite over hypotenuse. Cosine of 0, adjacent over hypotenuse. The tan of 0, opposite over hypotenuse. 0, 1, 0. I can also read off it for 90 degrees. There you go. Ooh, tan 90, 1 over 0. Undefined. You can't divide by 0, so that one is actually undefined. 180 degrees. Well, 180 degrees, is that in the second quadrant or the third quadrant? Well, it's in both. It's the boundary. So sine, second quadrant it's positive, third quadrant it's negative. Well, if it's both positive and negative, it must be 0. It's the only thing it can be. Whereas cosine, second quadrant it's negative, third quadrant it's negative. So it's definitely negative, and it would be the same as the cosine of 0. So I get negative 1. 270, there we go. Oh, negative undefined. Well, still just undefined. We don't call it negative undefined. And then we'd be back to 360. Reality is, with boundary values, you can just punch the button on your calculator. It's going to come up 0, 1, negative 1, or error on your calculator would be the undefined. So if I have to draw graphs, basically we plot those boundary values. So for the sine graph, I know it's going to go up to 1, down to -1. And if I plot every boundary value, so every 90 degrees, I'm going to start with 0. The sine curve at 0, sine 0 is 0, we saw. So I'll plot that in. Then the next boundary, 90, sine 90 was 1. And then basically each of those boundary curves will go down and then up, and then down, up, and then the other way as well. And the only thing we have to be careful with, of course, is this is not like those wonderful dot-to-dot puzzles you used to get as a kid. And you just draw straight lines. It's a smooth curve. Here we go. Whee. Y equals sine x. Now, let's have a look at some of the interesting features we've been talking about. Domain, that curve would keep going in both directions. All real x, you can find the sine of any number. The range, however, will only get answers between -1 and 1. And it has what we call a period. Trig graphs have a period. How long does it take for the curve to repeat? it takes 360 degrees for this curve to repeat. Oh, it's an odd function. Look at that, it's got rotational symmetry. Spin it 180 degrees, you get the same shape. So that tells me sine of negative x would equal the negative of sine x. A function negative x is equal to negative of function x. Cosine. Cosine starts up at the amplitude. Cosine of 0 is 1. So I'll plot that one in. The next boundary value, we're down to 90. And then again, that pattern repeats. Down and up and down, up and down, down and up. Go the other way. And whee, there's our cosine curve. They are very similar curves. In fact, they are the same curve. It's just that the sine curve and the cosine curve has been shifted horizontally. How much? Have a look at the top picture. Have a look at the bottom picture. How much has it been shifted? How much do you reckon? 90 degrees. You get the top one, shift it left 90 degrees. See how you get the same picture? 90, there's that number again. Not a coincidence, they're complementary ratios. So you shift one 90 degrees, you get the other one. So, because they are the same curve, but one's just shifted, domain's the same, range is the same, period's the same. Interestingly though, it's no longer an odd function. It's now an even function. It has an axis of symmetry. And so even function tells me cos of negative x is equal to the cos of x. Function negative x is equal to function x. Let's have a look at tan. Tan's a little bit more interesting. Boundary. Notice there's nothing on the y-axis because we had naught and we had undefined, and that's all we really had. So I'll plot in naught, undefined, well that's going to become an asymptote. And that pattern repeats. So naught. Now we draw the curve in. Whee! There we go. That's the basic tan curve. When you are drawing it, be careful. It is not a cubic. A lot of people make the mistake of drawing it like a cubic and going flat. A tan curve, or the tan of x, should come through at 45 degrees. And so that should be at 45 degrees. And that branch repeats between all of the asymptotes. There we go. So, domain. This is an interesting one. How do we write domain? You see, I wrote a big box for this one. It's all real x except for all these asymptotes. So except when x is 90, but then every 180 degrees before and after. And so a way of writing that without putting every possible value down is I can generalize it. And I say, well, okay, it's going to be 90 plus 180k, where k is any integer you like. So you can add or subtract any multiple of 180 and you'll get an asymptote. Range, all real y. That one has no breaks in it as you go vertically. Period for this one's only 180 degrees. It takes 180 degrees to repeat. And it's an odd function. It has rotational symmetry, this one. So that means tan of negative x is equal to the negative of tan x. Oh, what's this graph I'm going to draw? I plotted in some boundary values. I'm going to draw cosecants. I'm not going to draw all the reciprocal graphs. But the way I can do it is combining this idea of drawing trig graphs with the idea that we saw before about drawing reciprocal graphs. 1 over function x. Cosec is the reciprocal of sine. So I'll just draw a rough sine curve in there to give me an idea. And when we were drawing reciprocal graphs, we said whenever there is an x-intercept, it will become an asymptote. So all of those x-intercepts become asymptotes. And the number 1 was important because when you turn 1 upside down, you get 1. So all of those peaks and the troughs we know are at 1. So they will remain 1 minus 1, 1 minus 1. Now, remember, whenever we were below 1, we went above 1. This is what we end up with. Whole series of U-shapes. They're going to bend towards the asymptote and they will always be above 1 because the sine graph's always below 1. And so there's a cosec graph. All right, enough of me talking. You don't have to agree. Exercise 4D, 4 dimensions.